Hey there, TouchDesigner developers. Welcome to another TouchDesigner tutorial. In this video, we are going to look at using texture instancing to create what I'm calling the 3D slicing technique. Couldn't think of a better name, so that's what we're going to call it for now. Essentially, what's happening here is we're taking a 2D top texture, we're creating a ton of instances, we're using texture instancing to apply cropped portions of that main texture to all of these instances, and then we're rotating those instances independently to get this kind of three-dimensionality applied to the original 2D image. You'll notice that we also get this nice moment where everything kind of settles back into place and it infinitely will loop with that animation applied. So it's a pretty cool technique. It's actually somewhat simpler, I guess. The animation portion is somewhat simpler than you would expect. The instancing and the texture instancing specifically is the most complex part of this, but it's a pretty cool method, and I hope that you will find it useful. I decided here to apply it to letter forms, as we are now in the month of May, and just for a bunch of people have finished up the 36 days of type that happens in April, so I thought I would take a little bit of inspiration from that and do some sort of typography, animation style work. So this can be applied to anything. It doesn't have to be typography, text, or anything of that variety. Any sort of 2D top texture can be input into this and have this effect applied, but I thought it worked particularly well for text. And before we take a look at the network, I did want to point out that as this is using texture instancing, unfortunately for all of the Mac users out there, this method will not work for you because texture instancing is not supported in the Mac version of TouchDesigner. So this will be more of, I guess, an informative educational video and not something that you can actually build. It is possible that you could use one of the 3D texture tops to create a pretty similar version of this, but that's kind of beyond the scope of this video and would be even more complex than what we have set up here. So with that, let's jump into the network itself. All right, so this is the network. It looks deceptively simple. The rendering portion is very typical, basic, almost rendering or instancing example with a grid being used to create the instances and a simple rectangle being the geometry that's instanced. Same goes for the output of that render. We're just adding a background, and then I've added my title text for the title card here. We're going to be making actually a square version of this here instead without that added text. The main kind of interesting component of this network is all of the stuff that is happening within this textures base comp. And that is actually, we owe a lot, actually most of this technique to Matthew Reagan's expertise. And in a video that he created a couple of years ago, which was called Advanced Instancing Puzzle Pieces, I believe, he covered how to take a texture and use the replicator to make a bunch of copies of that texture and crop them so that you could then apply them to instanced geometry. So we're using that same fundamental technique here, but we are modifying it so that it is a little bit more flexible than what was set up in that tutorial. In this case, instead of having a preset grid size, we are giving ourselves the opportunity to modify the grid that we're using for instancing and thus the textures that we're generating so that we can try and experiment with different sizes of cropped textures and different sizes of instance geometry. So that's something that I think will be pretty great and will provide a good learning opportunity for anyone who hasn't messed with this a whole lot yet. Everything else, this is just a simple chop signal to apply those instance textures to our instance geometry, and then we just have a simple phaser chop based network that actually does the animating of our instances. And then I've added keyboard control so we can switch that on and off if we want to. So yeah, it's a lot in terms of the texture instancing, but everything else is pretty straightforward. So we might as well jump in. So I'm just going to delete everything as usual, and then we can get this thing started. All right, so what we will do is start with our simple SOP network, our grid SOP for the generating the instances. We'll attach like the basic rendering pipeline to it, and then we'll get into the more fun and advanced stuff. As I said, the everything else besides that texture instancing is pretty straightforward. So we're going to start here with a rectangle SOP. This is going to be the geometry that we actually create instances of. So I'm going to hook that up to a null first of all, and then the only major modification I did here was bump the size parameter to 1.001, and that just allowed me to have a little bit more seamless coverage, which we'll look at later. The instances will sometimes have a little bit of a space between them, and bumping it up helped in certain situations to have more overlap and make it look more seamless. But anyways, we won't worry too much about that now. Let's hook up a geometry to the null. So right click on the output of that null, SOP, come to the comp page, grab a geometry, comp, put that down, and then we will grab ourselves a constant material, first of all, and a camera. We don't need a light because we are not going to be lighting anything because we aren't really doing any shading with our constant material here. So first of all, let's take that constant, drag it on our geo, assign it as a material. We are good to go. And then I want to make sure, because we are going to have some textures with transparency to them, that we flip on the blending transparency switch to on. And then I'm going to turn the depth test off. And that just isn't really crucial at this point, but in certain cases it helps to make the instance geometry appear a little bit better on our final render. Speaking of rendering, let's grab ourselves a render top. Oops, not a remap, but a render. Place that down here, and we will attach a null. And then we might as well also comp a background in, even though we don't really have anything to look at yet, just for when we get to that point. So I'm going to do this via a transform. You, of course, could composite in anything you want, including a constant or something else. For my transform, I'm just going to set the alpha of the background color parameter to 1, and then I'm going to flip on the comp over background color switch, and we now have a black background. The other thing that I did was I modified the resolution of my render. I wanted it to be a square, so I set it to 1024 by 1024, and that allows us, all of us who do not have a commercial license for TouchDesigner, I kind of wanted to keep it within that resolution range. So that's what we're going to do for this one. After that, let's grab ourselves a grid SOP so that we can start generating some instances here. And we're going to attach a null to that, and then we could call this position, or we could call it instances. It doesn't really matter. I guess I'll just use POS for position because it's short and sweet, to the point. So that is going to generate our different instances for us. Let's go ahead and turn instancing on within our geo comp. And then we're going to use the POS null SOP here for our translate operator. Go ahead and grab the P0, 1, and 2 channels to make those instances. And it doesn't look like anything has happened, but actually we've now generated, let's see, 400 instances of our geometry, believe it or not. All right, so from here we could start working on our texture instancing setup. But one of the things that I want to do before we do that is grab that constant chop that I used in that version I just showed, which again is being used to set the size of the grid that's generating those instances. Okay, so apparently my video recording of this actually paused for a good chunk of time right at this point in the video. So we're going to try to kind of pick up the pieces and insert what was done here and then cut back to the original. But we were just at the point of adding this constant chop, which is going to be used to set the size of the grid, and actually a variety of other parameters will all be connected to that. So first thing that we will do, I'm going to rename this chop to grid size, and then I want to rename the chop channel to size as well. And then I'm going to set that value to 10. So this is going to be what is setting actually the number of rows and columns within the grid SOP. So it's setting like the density of the grid, and it's going to be also modifying the size parameter of that grid, along with some camera position adjustments and some other stuff that we're going to build in just a minute. So the first thing that we can do, though, we might as well make that chop reference right now for the rows and the columns. We're only going to be dealing with textures and images that are in a square resolution, so our grid is always going to have the rows and columns are going to be the same values because we have a 1-to-1 aspect ratio. So we're going to use the size parameter for both the rows and the columns. The other thing that we need to do is that when we bump up the number of rows and columns, we're actually bumping up the number of instances. And because the rectangle SOP that's connected to everything here is not changing size, when you add more copies of it, they're all going to kind of be overlapping on each other. So at the same time that you're modifying the number of rows and columns, you also need to be changing the size of this grid as a whole so that it spreads those instances further out in space. And so we're going to do the same thing. We're going to create a chop reference from this size parameter. However, and I did that again by dragging over the title size here instead of independently to each one. However, we need to actually, as you can see when I've done that, we have some space in between the instances now. And so I found that by subtracting 1 from both of these parameters, you can remove that spacing in between those instances, and it will allow for a more seamless texture when we get to that point. The other thing that I want to have some control over here is the position of the camera. So the camera, as the scale or the size of the grid increases, that means that basically the overall geometry that we're generating is going to be increasing in scale as well. And so if our camera is not responsive to that, it will fill up the entire screen and you won't be able to see the whole texture anymore. So I found that if we make a chop reference to the translate Z parameter here, and then we multiply that by 1.5, we can get a camera position that will always keep all of those instances within frame and always have a little bit of space around them, which is nice. So those are the main things that we're going to attach this to for now, but we are also going to apply it to 1 or 2 other things in the future. So since we finished that up, we can grab ourselves the text top that is going to generate our texture for this particular example. So I replaced the derivative text with the letter R. I did this because I wanted to highlight this specific letter form design of this particular font that I chose, which we'll look at now. So I opened up the font thing here, and on my computer I had a font called, wherever it is, Franklin Gothic, and Franklin Gothic Demi is what I ended up landing on. I really liked the R letter form for that particular font. So we will need to bump the font size up though, so that it takes up more of the space of this texture. So I ended up going with a font size of 1000, and you'll see that actually takes over everything and is way too big because our resolution has not yet been increased to the value that we want. So we will take care of that now. If you come to the common page, we can flip the resolution to 1024 by 1024, and now it fills up a good portion of the screen. And that was all, I believe, the parameters that I modified with that particular operator. So now that we've got our text top all set up, we can actually hook up a base comp within which we're going to do the generate those textures that we will use for the texture instancing. We're going to be using the Replicator comp, as I mentioned before, to create a bunch of copies of this texture and crop them so that each instance has its own small crop texture corresponding to it. So let's start by right-clicking on the output and grabbing ourselves a base comp. And then before we even jump into this thing, I want to actually add a couple of custom parameters that we can access from outside of this base comp. So that's what we're going to do. But actually before that, let's make sure that we name this base comp textures. And now we can work on adding those custom parameters. So the reason we're doing this is because we want a couple of these things to be accessible without having to jump in here and make some changes. So let's go ahead and right click on it, hit customize component, and this is where we can start adding some custom parameters. So I'm going to be adding 2 integers. So the first thing I'm going to do is flip this float type to integer, and then the first one that I'm going to use is going to be called resolution. And this is going to be a parameter, so you can type the name in there and then hit add parameter. We're going to have a fit top inside of this base comp, which is going to take whatever texture we input into it and always make sure that it's within a 1:1 aspect ratio and at whatever particular resolution we want to use. This is giving us some flexibility in case, people have a commercial license or something else and want to bump the resolution up, or for whatever reason, if you want to make it smaller. We're going to have the ability to adjust that outside of the operator. I'm going to change the parameter name to res just because it's a little bit shorter and easier to reference when we eventually have to type it out later on. And then I want to set up a couple of things here. I'm going to set a default to be 1024 for this parameter. And actually, why don't we go ahead and look at the custom page and see what's going on. So we've got our default of 1024. We could set range for this slider if we want to. We might as well. Why not? It's not like we're really going to be experimenting, I guess. Well, maybe you could be with the resolution via a slider, but since it's there and we're here, let's just give ourselves, 1 to 1280 because the non-commercial version maxes out at 1280. And then I'm also going to add some clamp values here, same exact ones actually of 1 to 1280, so that if someone were to type in 3000 for the resolution, it will automatically clamp it to the maximum value that's allowed. And again, we're just doing that because if you were to go over that resolution on the non-commercial version, it wouldn't allow you to use that resolution. If you have a different version, or if you don't feel like setting those, you're more than welcome not to do that. That is it. We're only setting one value here because, again, this is going to be always a square, so we don't really have to worry about length and width being different, or width and height, rather, being different. The other parameter that I want to set up is called grid size. And again, it's going to be an integer. And we're going to change the parameter name, again, to just size because it's shorter. What we're going to be doing is grabbing the current value from our constant chop here that sets the size of our grid that generates the instances, and we're going to connect it to this parameter so that it's available for use inside of this operator. Obviously, you could do chop references or anything else to get the same sort of thing going on, but I figured we would just do it this way. All right, so I'm going to set my default to 10. Again, this is going to be a chop reference, so we don't really have to set this up, but I guess if you wanted to, experiment on your own or change some of the stuff, there's always the option to do so. We need to have a range minimum, in this case, of 1, because we don't want to have 0 instances. I set my maximum to 40 because that is quite a lot of instances. If we think about it, you have to square this value to calculate the total number of instances that will generate. So that would mean 1600 instances, which is a lot for an older computer and maybe even a newer computer too. So I kind of capped it at that. I set my clamp minimum and maximum to be the same. And that means that now my slider goes between 0 and 40. And just to confirm, the one above that goes from 1 to 1280. So I want to set these back to their defaults, which was 1024 and 10. And the last thing I'm going to do here is just change this custom page name to parameters. Custom didn't really mean anything to me, but I guess parameters is kind of vague as well. So yeah, you can definitely make your call on that one. That is actually everything that we have to do here. Actually, the one thing I will do, let's make that shop reference happen right now so we don't forget about it. And so it's available later on. And that is it. I guess we will jump back into the original video now. All right, so now that we got that all done, we can actually go inside of this thing finally and start making some stuff happen. There are quite a few things that we have to do inside of this. We had a chop network, well, 2 chop operators up at the top there, and then we had a DAT network, which gave us some crop values. We had a replicator. We have to do all that stuff. But before we do that, I'm just going to start at the most basic level with our texture here, which we need to first use a fit to make sure that we are taking that texture and putting it within a resolution and an aspect ratio that makes sense. And then I'm going to attach a null to that fit. And just like Matthew Reagan's video, we are going to call this null img. Perfect. Let's also bring a parameter chop in, because the parameter chop is going to bring in those custom parameters that we set on the outside of this base comp. You can see they are appearing here, and that's awesome. And we are going to rename this, I don't know, to grid space par, just so we know that these are parameters being used for the grid. Now that we've got that set up, I'm going to grab a constant chop, and we're actually going to use these 2 chop channels to calculate the actual pixel width and height of the cropped little square textures we're going to be generating. So this is going to be pretty simple, but I guess we will call this channel, I don't know, maybe like crop_res, so that we can differentiate it from the res that was coming in from the custom parameters. And then we're gonna have to write ourselves a quick little expression here to get that value. So what we're going to do is we're gonna take the resolution channel and we're gonna divide it by the size channel, and that'll give us the number of pixels wide and tall, because we're dealing with squares, that each one of these crop textures should be. So how do we do that? Well, we'll type in operator, and then the operator's name is grid_par, close parenthesis. Then we need to get a specific channel. We need the res channel for the resolution, close bracket, and then we need to divide that by, well, I'm just going to copy this first portion here. We need to divide that by the size channel, and that will give us 102.4, which is again, the pixel width and height of each one of those cropped textures that we'll be using. So now that we've got these set up, I guess what I'll do here is name this, I don't know, crop parameters or crop resolution or something. Why not crop resolution? Because we're not going to be adding any other parameters to this. Now that we've got these set up, I am going to take an extra step here that just to make our lives a little bit easier. It's not really necessary because this isn't like the most complicated series of base comps that you'll deal with in TouchDesigner, but just so that, you know, any beginners who haven't done this before and or just for our own sort of sanity and convenience, we're going to use something called internal operator shortcuts to access these values, because we're going to be creating at least 2 other base comps within this, which will be grabbing this information from. So in order to do that, let's come back out, and we need to grab an external parameter window for our textures base comp. So let's just right click on it, grab the parameters window, here it is, and flip it to the common page, and you'll see we have something called internal operator shortcut. And that is where we can create those shortcuts. So let's come back within this operator, and I'm going to start with the grid parameters, and then I'm also going to add the crop resolution because we're going to use both of them. The shortcut is the name that we're going to be assigning to this. So I'm just going to call it the same thing, grid parameters, because we know what those are. And then I'm going to drag the operator here, and now I can access it via a really quick expression, which we'll look at momentarily. And then I'm also going to grab the crop resolution operator, and I'm also going to make a shortcut for that, crop underscore res, so we can access that chop channel anytime that we need to. All right, that is all that we need to do for those shortcuts. So now that we've done that, we can actually start building our DAT network, which we're going to use with that replicator later on. We're going to start with a table DAT, and there it is. And we're going to, we need this table DAT to be a single column. So we're going to flip on exact dimensions. We're going to set our columns to 1. And then we need the number of rows to be equal to the total number of instances. So we're using the size parameter to set our total number of instances, if you remember, and that is being used for both the row and the column parameters. So we can actually just take the size parameter, multiply it by itself, and it will supply us with the number of rows that we need. So we could do this with our operator shortcuts, or because it's in the same level that we are in, we could make a chop reference. And I think just because it's here, let's just do a chop reference. So I've made a chop reference, it's set to 10, but again, we need to multiply this by itself. So we're going to copy that and add multiply. So now we've got 2 of those, multiply, we should get 100. And that's correct because right now we have a 10 by 10 grid. So the reason that we're doing it this way is that it will be flexible when we change that constant chop outside of this operator, and it'll allow for our table to flexibly change size to accommodate that. Perfect. So now let's use an evaluate DAT because we need to fill this table. And this is going to be pretty straightforward. All we need to do here is we're creating our index values, and so we need to write a very simple expression that fills these with numbers, me.input row plus 1. And again, that's just going to fill each one with a number, starting with 1 and going to 100 at the very bottom. Then we are going to start doing our more complex calculating that we need to do for the crop parameters. So we actually need to hook up a base comp. That's how Matthew Reagan approached it. I think it's a pretty organized and nice method of doing this. So that's what I'm going to do here. We got our base comp, and we will need a null, so I'm just going to attach a null. Why not? After the base comp. And then we can go inside of the base and start doing some stuff. So this time, this is where our internal operator shortcuts are going to come in handy. This time we need we need 2 tables, actually. We need one table that is set to the dimensions, the rows and columns, essentially, of our grid SOP way back out, creating our instancing. And then we need another one where we're going to write an expression to fill that table. So the way that we're going to approach this is why we did our internal operator shortcuts. We can, instead of having to worry about our ... / kind of stuff to go up layers and try to figure out where operators are located, we can use the shortcuts IOP, internal operator, dot, we need, in this case, grid parameters, grid par. So it's referencing that grid par chop that we have up a level from here. And then we want to grab the size channel from that, because that, again, is like the width and the rows and the columns that are found within that grid SOP. So that should give us 10. And because we're dealing with squares here and nothing else, we are going to use the same reference for the second one. And again, this is allowing us to flexibly change the scale of this table depending on how many rows and columns our grid SOP has. Matthew Reagan's tutorial had a specific number of rows and columns that were set, and so it wouldn't allow you to come in and start to modify the scale of that grid. And we're trying to counteract that by adding this ability to modify some things. We're going to add a second table, as I was just mentioning, which is going to have a simple expression in it, which we're going to use to fill in all of the different cells within that table. I'm going to hook up an evaluate dat now because that's what's going to be used to take that expression and fill this up. Let's click our viewer active here, and this is going to be just actually a pretty simple script that's going to once again use our internal operators. So here's how we can start to fill up those crop pixel values. me.input row times, in this case, I operator or internal operator dot crop res. We want to grab the crop resolution from that crop resolution chop that we calculated just a moment ago. We want the channel called crop underscore res as well. And that will give us what we are looking for in the X direction, or the rows rather. And then we need to do the same thing for the columns. So me.input col times, and then we can actually use this same expression here to grab that crop resolution again, because we're dealing with squares. And that has now, because it's connected to our eval, generated us all of the different X and Y crop settings that we need for our crop top that we're going to be using in a little bit. Now, what Matthew Reagan did in this part of the network was, I believe, convert the table to text or something like that, and then basically took all of the information found within all of these cells, and instead of having it displayed in this table which has a specific number of columns, he took that information and had it all display within a single column. So it's like as soon as this set of data would end, this next set of data would fall right underneath that, and so on and so forth. Because we want this to be flexible, again, to a table that will change size as we set our number of instances differently, we are going to achieve this in a different way, which is done via a Script DAT. And so this is another, learning moment for anyone who hasn't dealt with this before. It's super useful because we can achieve those similar sorts of things that Matthew Reagan was dealing with in that video, but with the ability to have our table have like a flexible number of rows and columns. So let's go within this little script operator here and start adding some stuff to this. So basically, what we need to do is we need to go through every cell of this table, and every time we reach a cell, we need to just add a row to our table and only ever have that single column with all of that information. So the way that we're going to do this, so the first thing that we're going to do is set up a variable called table, and that's going to equal script ops.inputs 0. That's just allowing us to reference the thing connected to the first input, the table in this case connected to the first input. And then we're going to have to use a series of for loops to go through and grab all of the information from that table. So what I'm going to do here is use my first for loop is going to be for r in table.calls, open and close parenthesis. You could use a different variable, c or x or whatever you want. And then I'm going to say for cell in R, and then within that we can set up a new variable called new cell equals cell. So it's taking that information from the original cell and putting it into this variable called new cell. And then we are going to, in our new table, append a row to that table, and we're going to use the cell's information is going to be whatever is contained within this new cell variable. And that's it. So if we then zoom out from here, oh, we have an error. What have I done wrong? Script ops. Oh, maybe I typed something wrong. Script ops. I'm missing an S. So make sure you have the S after script ops. And now, okay, still getting an error. What am I doing wrong? Script ops. Oh, okay. It's not script ops, it's script op. My mistake. Okay. Once you fix that, there we go. It's happy. All right, so now we have all of that information in our table, just the way we wanted, single column. Every time that we had a new column of information in the original, it's just been added to the end of the table and so on and so forth. So that solves our problem. So that means if this table ever changes size, this script can deal with it. After that, Matthew Reagan did something where I think he converted the table to text and then back to a table in order to split the information in the cells into 2 columns instead of just 1. We actually don't have to do it that way. We can just use the one of the convert DATs, and instead of splitting cells at tab, just delete that and hit your space bar once. So it's splitting the cells at space. It'll do the exact same thing without having to convert to text or do anything like that. So that's all set up and done. And then we can merge this with our original information so that we can make our final table wherever the merge operator is. There we go. All right, merge, and then we want to not append rows but append columns, and you'll see now we have an index value, we have an X value, and a Y value. Finally, we're going to use an insert chop to add some labels to the top of this table, or not an insert chop, an insert DAT. And all we have to do here is in the contents section, type in index space X space Y, and that will give us some labels. So now we've got index in the first column, X and Y in the second and third columns respectively. And that is actually everything that we are going to be dealing with within this base comp. We've got ourselves the table that we can use to make those replicas with the replicator. And we might as well add the replicator in now. So let's drop that down. There are going to be some things that we work on modifying within this replicator in a moment, but the first thing that we need to do is create ourselves a master operator, which is basically the master thing that is being replicated with the replicator over and over and over. And you know what, before we do that, let's shift everything in our network over to this upper left quadrant, because when we use the replicator, it's going to generate, by default at least, all of our replica operators down here in the bottom right, and they would basically be overlapping potentially some of the stuff we've built before. So let's move that there, and then we're going to grab ourselves another base comp, and this is going to contain our master operator network. So I'm going to call this master 1, and then within that we're actually going to pull this texture in and do set up a crop top, which is going to be the thing that sort of drives the cropping functionality through the replicator. So to get that texture in, the first thing we need is a select top, and after that let's grab that crop top. And then Matthew Reagan composited text over his texture at first just to see where each instance was ending up, but since we're not actually changing the order of those instances in space, we're just rotating them, I don't think it's really necessary for us. So let's not do that, but instead just attach a null to the end, and preemptively we're going to title this final so that we don't have to deal with that in a moment. But we do need to bring our texture in, so let's grab that by typing in .. /img, and now the texture from the R that we had above, or one layer outside of this, is now within our base comp here, and now we can actually set up our crop top to do the cropping that we want. The first thing that we should do is set our units to pixels in all of the different crop parameters. And then we need to, let's see, oh, I see we have missed something. We'll have to set our resolution in a moment. But all right, let's go ahead and set these crop parameters. We're going to write ourselves some simple expressions to do this. And the way that we're going to do that, let me just go ahead and check my notes here to make sure that I've got this down. We are going to look for information within the null1 operator that is one level up. So // That's actually the table that we connected to that base comp that was doing all those calculations of the cropping pixel values for us. And then the specific cell that we want to grab from that table, we are going to grab the row based on this expression me.parent.digits, which is going to be grabbing the particular number at the end of the base comp, the replica base comp that we'll be generating. And then we want to grab the corresponding value from the X, the column with the label X. And so you'll put X within single quotes there and then close out those brackets. Should be 0. That is exactly what we're looking for. We're going to use the same thing for the crop right parameter. However, we don't want our crop here to be 1 pixel wide, or actually, 1 pixel wide. We need to grab that crop resolution actually that we set up out here. We could do this with a chop reference. We could do this with a internal operator. Doesn't really matter. I guess we'll use the internal operator because it's easier. So plus iop.crop_res, and we want the channel crop_res from that operator. Oh, let's also add spaces to follow our kind of formatting. Hit enter. We should be getting 102.4. Perfect. And then for the crop top and bottom, we can actually copy the same thing, except we are going to reference, in this case, the Y label or column within that table instead. So you just want to change, copy and paste this first one from crop left to crop bottom, but change that X to a Y. And then we'll copy that and paste it into the crop top parameter. And we need to do the same thing here where we add the crop resolution on to the end. And that's it. So our crop settings have been successfully applied. And once we start creating replicas of this thing, it will crop correctly. Now, what I was talking about a moment ago that I realized was wrong, I forgot to set within our fit top the 1024 by 1024 resolution that we are going to be using. And that is why actually we set up that parameter within our custom parameters for this base comp. So let's grab that and make a chop reference from that resolution chop channel to the resolution that fit. So we're almost ready to go. Within the replicator, we have to do a couple of things. So we need to grab our master operator, drag that over to the master operator parameter. Then we have to grab our null1 DAT and drag that into the template DAT table. And you'll see that's created a bunch of copies, which is awesome. There's one other thing, though, that we have to do before we can start messing with this. Well, actually, two things. The first thing, which we're going to follow Matthew Reagan's sage wisdom here, is we're going to set this master base comp to be a clone master of itself. What that means is if we recreate all the operators after we've done that, you'll see there's all these lines attached to all of those different copies now. That means if we modify anything within here, like if we add more textures or whatever to it, it will then appear in all of these different copies. So that's a super useful technique. The other thing that we have to do is the replicator comp has a maximum operators parameter. And this is how you can set a limit on how many replicas of that master operator can be made. In this case, we are going to create a limit that changes based on the size of this, the value of this size parameter. This is maybe not the best idea if you are going to crank the size up to like 100 or beyond. You have to remember that the size parameter, it's not that we have 10 instances being generated, but we have 100. So if you crank that up too high, it's really going to create a ton of instances and a ton of replicas of this master operator. So that's why outside of this, we did set that limit of 40. So in theory, you could set it higher depending on your computer's performance, but I just want to kind of give you that caveat that there could be some performance issues of doing so. So with that said, I guess since we're trying to make this flexible, let's just use this chop reference here to set our maximum number of operators. And again, we need to multiply this by itself to get the total number of instances that we have at the moment. Since we set our limit to that parameter to be 40, in theory, we'd only have a maximum of 1600 that we could crank this up to. So in that case, I guess we don't even really need a chop reference modifying this maximum operators. But it's kind of up to you how you want to set that. Either do the chop reference or set it to 1600. I think even that value of 1600 is probably going to be very taxing on at least this computer. So anyways, that was actually everything for this part of the network. We are actually generating, if we go inside one of these, cropped textures at the correct resolution, and we can now reference those within our GeoComp to get those textures actually applied to our geometry. And again, we have to really give a big shout out to Matthew Reagan here for showing this technique in that video from a couple of years ago. It was super instrumental for putting this whole thing together. All right, so let's start by doing that, adding those textures to our instances. This is found on the instance 2 page, and you'll see all the way at the bottom we have instance textures and a couple of other things. So to look for those instance textures, we need to look within this textures base, and then there's a ton of base comps called item with a number after them. And then inside of that, there's an operator called final, which has the actual texture that we're looking for. So if we come way back out here, instance textures, we want to look inside of textures, and then we want to grab all of the operators that have item as the first part of their name. So if we do item and then asterisk, it'll grab all of those for us. And then we want to grab within that item base comp the operator called final. And you'll see everything is turned black, which is fine. We then need to set up a chop or something else, another kind of operator, to tell our GeoComp where those textures should be placed. Right now, it's basically taking the texture right here, which is blank because it's probably one of the corners of this original piece of, or this original texture, and applying it everywhere. So we need an operator that is going to allow us to apply those textures correctly. And the way that we're going to approach this in this tutorial, at least, is using a pattern chop. Matthew Reagan used a wave chop, I believe, but they both do basically the same thing. So I'm just going to hook up a null to that and call this index, and that is going to be what provides the texture operator index. So we've got that set up. Let's make some modifications now to the pattern chop so that it can actually give us the correct index information. The first thing we want to do is change this length parameter to match the total number of instances that we are generating. And that can actually be gathered from the number of points that are found within this position null SOP that we set up earlier. So we're actually going to make ourselves a little reference to that operator. So let's grab the operator called POS, and we want to grab the number of points from that operator. And what have we done wrong here? Oh, right. Num points needs to have a capital P in order for it to work. So make sure it's lowercase num, capital P in the points. So perfect, it's grabbing the length that we need. So we now have a corresponding value for every one of the instances. However, the type of waveform that we're looking for here is not a sine, but actually a ramp. And that's because we want each one of our different instances to have the corresponding number texture applied to it. So we want the first instance to have the first texture, second to have the second, and so on and so forth. The other thing that we need to do here to make this work correctly is we need the range not to be between 0 and 1, but between 0 and the maximum or the total number of instances. So we're actually going to copy and paste this same exact reference and add it to the toRange parameter below. And in this case, we actually need to subtract 1 from that total because we're starting at 0 and not at 1. So if we did 100, 0 to 100, we'd actually have 101 numbers or instances in our channel here, which is not what we want. So that is actually all we're going to do for that operator. We are set and ready to go to apply this. So if we grab that index operator and drag it to texture index operator here within our GeoComp, and then grab the channel 1 for the texture index, we should now see the R. The R is now appearing on our many different copies of that rectangle SOP, which is great. However, what we might notice here is that we have lines at the kind of meeting point of those different instances. It's not a very seamless texture. We can see this little kind of odd grid going on. And we can actually correct for that by changing just 1 or 2 settings within this instance textures section of our GeoComp. If we click that little double arrow, it brings up this drop down where we can modify some settings about how these things are being textured. And all we need to do here is we can change this extend U mode to hold and the extend V mode to hold. And you'll notice that immediately we now have a seamless texture once again. And that is exactly what we're looking for. So we've done pretty much all of the heavy lifting here. The only thing that remains is to add the animation to this thing. Even though it just looks like we have a solid R, we actually have a bunch of little squares that make up this R that can be modified however we want. And the way that we're going to do this in this video is done via the phaser chop, which, as I mentioned before, is a newer operator that's been added to Touch, which is really cool. And let me just turn that display off so we can see a little bit better of what's going on here. We're going to make some modifications to this thing, however. We want to attach something to the first input, which is the time input, and the second input, which is the phase input, because we want to change both the speed at which this chop channel is changing, and we want to change the content of it. We don't want it to just be this kind of sloped ramp kind of shape. So I'm going to attach for the first input an LFO, which is going to stand in for or be our time channel. And instead of making it leaving it as a sine wave, I'm going to use a ramp wave. And then I'm also going to slow down the frequency quite a bit to 0.125, and you'll see here that that causes our phaser to output the chop values at a slower rate, which is perfect. The other thing that I want to do is attach a noise chop to the second input because we want some noisier data coming out of this thing. We want our individual instances to rotate at different kind of degree values so that they're not all aligned. And we're going to achieve that via the noise chop. So the first thing that I want to do with that noise chop is I can connect it, but I do need to set the length of this chop so that it matches, again, like we did here, the total number of instances that we are creating right now. So I'm actually just going to come back within this pattern chop and copy and paste this same expression that grabbed the number of points from that position null. And I'm going to apply that to the end parameter within the channel page of my noise chop. hit enter, and we have 6,000 samples, which is not 100 samples, which is what we want. So the reason that's happening is because we're still on the seconds unit for our end parameter. We can set that instead to frames, and now we have ourselves a chop signal that is giving us the total number of frames that we need for our instancing. I want to make a couple of other modifications to this noise chop though before we apply it. It's not really giving us all that much variety in its content right now, and that's because the period is set a little bit too high. So if we set this period to something like 0.01, for example, we get a noisier and a choppier output, which basically is going to correspond to our different instances having a wider variety of rotation values. And you can play with this a bunch to get different looks, but that setting gave me a pretty good output. The other thing I'm going to change, maybe set the seed to something else like 5 or 10, or it doesn't really matter. And now we have this choppier data that is going to be used to rotate our instances. However, if you notice, it's going between just 0 and 1 right now, which is not really going to give us any noticeable rotation. So we're going to have to use a math chop here to scale that information up. And if you come to the range page here, we're actually going to scale this up quite a bit. We're going to have the to range fall between 0 and 720, so that every time that this phasor goes from 0 to 1, it's actually going to rotate our instances 2 times. Remember that 360 degrees is 1 full rotation. And then we are going to hook up a null to that, and we're going to call this rotate. Keep it simple. We can actually attach this now, and then the last thing that we're going to look at is just adding some simple keyboard control to that LFO so we can turn our animation on and off. But you know what, we've been working so hard to get this thing set up, we might as well see how this looks. So I'm going to flip on the display. We're going to come back into our GeoComp, and then on the instance 1 page, we are going to come to the rotate operator here, and we want to apply this channel to rotate Y. So we're going to grab channel 1, and now you should see a very similar form of that animation that we saw at the very beginning now occurring on your screen, which is awesome. And again, like I said, you can modify this noise significantly. You don't even have to use a noise or a phasor for that matter. You can use whatever kind of chop operators you want. Or I guess chops, since it is channel operator, saying channel operator operator. You can use any kind of chops that you want in order to achieve different looks. But I thought that the phasor chop provided a pretty interesting animation, and I really like how it always comes back to this like whole solid form before it repeats the animation. Let's go ahead and set ourselves up some keyboard control over this animation as well. All I'm going to do for that is grab a keyboard in chop, and then I will attach that to a logic chop wherever it is, somewhere in here. Oh, it's over here. Okay, got that. And you know what, might as well hook up a null too in case. Just in case. I mean, we don't really need it, but for good measure, we'll do it for the kids. Logic chop, we need to set our channel preoperator to toggle, and that is going to allow us, when we hit the 1 key, to have that chop channel turn on and off, which is perfect. And we can then use this and apply it to the reset switch within the LFO chop. And the reason we're doing it to the reset switch is because it will reset it to 0, which means that our shape will appear, or our letter will appear in its whole kind of form. And then as soon as you turn that off, it'll start the animation from the beginning. Whereas the play setting will pause in the midst of an animation and hold it there instead. So I think the reset is better for actually allowing you to kind of hold it in that initial state if you so choose. So again, we're just going to make a chop reference to that reset switch, and with that we should be able to hit the 1 key, have it stay in that solid form, and then whenever we want, turn it off and have the animation start once again. So one final thing before we go. you can hook up anything that you want to this textures base comp. It does not have to be this typography. It can be anything. So for example, we can hook up the good old banana, and although that's not really that large of an image, it's still chopping it up into multiple different boxes, which is awesome. You can also, play around with maybe using a transform or something else to make the scale of this thing within that bigger, or, even within here, I guess. You could play with the fit mode so that it kind of fits in there, or gets a little bit more animation applied to it. But I just wanted to show you that, you don't have to deal with just the text. You can really do whatever you want with it. The final thing that I will cover here, let me just set my fit back to default, even though it's not really doing anything in this current situation. The final thing that I wanted to say is that you can now, with this grid size constant chop, you can set the size parameter to whatever you want. So if I set this to 5 or maybe 6, we now have fewer divisions in our grid, and we have larger pieces basically that are being rotated. So you can get different looks by modifying that parameter. So we can crank that up to something like 20 and still get the same kind of animation being applied, but have a lot more different divisions of our texture. And we can even crank this up to something like 40, and my computer is probably going to seriously struggle here, and still, again, have that same animation be applied, but way, way, way more instances generated. So yeah, you can play around with all this stuff. I really would recommend messing with the animation and actually especially the textures, because you can really get some interesting stuff, especially with any textures that have an alpha channel like this one, that really will kind of give it this interesting, like, broken up feel. So I guess we will close out the video there. I hope you've enjoyed this video and have found this technique interesting. This has been another TouchDesigner tutorial. Like and subscribe. As always, I will be continuing to make more and more TouchDesigner videos here on YouTube. You can always find me on Instagram as well at the username @JackDelora, which should be appearing on screen now. Same name as this channel that you're currently watching this video on. Unlike previous videos where I had a specific hashtag for the technique, I think what we'll do from now on, if you try this technique out for yourself and you feel so inclined, you can use the hashtag #TD tutorial on Instagram or elsewhere to tag your work. I'm just curious to see how different people take this and start interpreting these techniques. And I think it could be an interesting way to add this sort of community aspect where we can all look and see how things have been interpreted. So again, use that hashtag #TD tutorial and we can find each other's work on Instagram or elsewhere. So with that, I will close the video out. I hope you've enjoyed this tutorial, and I look forward to seeing you in the next video. Thank you so much for watching.